Hi, I'm Jesse with Mastercam. In this video, we're going to be looking at a few different ways you can determine projection length for your tooling in Mastercam and how to use the M130 command to have this information displayed on the controller for the operator to see. The Haas Next Gen control includes a media display function via a simple M code, M130. This function allows you to use an M130 command in your NC code to have the control display an image or even a video with sound. In the example that we'll be looking at, we're very early on in the process of developing and proving out a new part. Since at this stage, there's a lot of back and forth collaboration between the programmer and the operator at the machine, it can be easy to lose track of changes between revisions, especially with things like tool projection. M130 is going to allow us to display a picture showing the tool setup and projection length so the operator can measure and verify that projection before proceeding. Before we get into utilizing M130, we need to decide on our tool projection. There are several ways to do it, and they all have their advantages for different workflows. We'll start with some dynamic roughing operations on this mold core for a computer tower. This first operation roughs the mold's shutoff surface. Since we're concerned with choosing an appropriate stickout for the tool, our first method of setting this value requires us to launch the toolpath parameters and navigate to the holder page. While we're on the holder page, let's take a moment to talk about the importance of the holder setup. In order to properly simulate our tool motion in backplot, verify, or machine simulation, the holder needs to be defined accurately. If we don't choose the correct holder to match what we're using in the machine, in this case a Hydroforce hydraulic milling chuck, then our simulation results may be completely inaccurate, leading to a machine crash or a broken tool. As we can see, the projection length is set to 1.25 inches. Let's look at this in backplot. This is an efficient way to get an idea of how the toolpath looks. Just click on any segment of the toolpath that you want to look at more in depth, and that tool will snap to that point. For this first toolpath, it looks like we have enough clearance throughout the cut, so we'll leave the projection as it's configured and move on to the next toolpath. Instead of looking at the toolpath in backplot, let's go to the Home tab and launch Analyze Toolpath. Make sure the tool and holder are enabled. You can move your mouse along the toolpath and the tool will follow. It appears there are some collisions between the holder and the part, so we'll need to adjust our projection length. Let's look at the first method for setting projection length. On the tool page of the second operation, let's right-click on the tool we're using and choose Edit Projection. This returns us to the graphics window where the tip of the tool is locked onto the mouse cursor and you can place it wherever you'd like on the model. Since we're concerned with the inner edges of this open pocket on the side of the model, we'll lock the tool there. You can then click and drag the holder up and down the shank of the tool to adjust the projection. It's clear that 2 inches is more than enough clearance at this location, so we'll lower that value to 1.75. This should still clear the part, and the shorter projection length will help keep the tool rigid, which will minimize any chance of chatter in the cut. When you press Enter, Mastercam will warn you that the assembly has changed. Back on the holder page, we can see that the projection length has been updated to 1.75 inches. This way of setting projection length may work for some situations, but it's just a best guess. In order to be more accurate and make sure that the projection length will truly be safe, Mastercam has an automated function that can analyze the clearance between the holder and the model along the length of the path. It will then provide you with the minimum projection length to use. On the Toolpath tab, launch Check Holder. After the function launches, we have the option to modify the existing tool or to create a new tool. In this example, we'll modify the existing tool. Under Collision Test Setup, we can enter some clearance values for the test to measure against, and then we can click Perform Test. Once Check Holder is done, it will report back a projection length that meets the tolerances we have provided in the test setup. ensuring we won't have a collision. Check Holder also color codes the toolpath to show you where a collision would have occurred. According to Check Holder, we need a minimum projection of 1.98 inches in order to clear the part with the clearance we requested. Let's round that up to 2 inches and click OK. Again, Mastercam warns us that the tool has been modified. Now when we look at the parameters for any of these operations, since they all use the same tool, the projection length is set to 2 inches for each of them. The next thing we want to do is take this information about the tool projection and make it visible to the operator. The standard way to do this is with a setup sheet. In the past, this report would have been printed out on paper and given to the operator. Now with the growth of Industry 4.0 and how interconnected our devices are becoming, distributing this information digitally is not only more convenient, but it's also better for the environment since we're not wasting paper. Digital setup sheets distributed to computers or tablets are becoming the norm, but M130 goes one step further by placing the information graphically right on the control. Let's quickly take a screenshot of the holder projection that's shown on the holder page. For this example, we'll use the snipping tool since it comes standard as part of Windows 10. We'll select the image of the holder, and once it is captured, we'll use the pen tool to circle the projection length to make it more visible. With the image file saved, we now need to trigger the M130 in our NC file. We'll do this by placing the insert arrow directly after the first toolpath. Then in the 2D gallery on the toolpath page, we'll select Manual Entry. We'll type in M130, then the location that the image will be saved to. By default, the location on the control will be user data / my media / and then the name of the image. With this line of code, the image will flash on the controller for a short time, but we need more than that. We need the program to stop and the image to remain on the screen so that the operator has a chance to measure the projection and verify it against the image. To do this, we'll place an MOO after the M130 line. Lastly, we want to make sure that this is output as code in the NC file. Let's post out all the operations. Once Code Expert opens, we can do a search for M130. The code has output between operations 1 and 2, as expected. Now all that's left to do is load our files into the control. First, we'll load the NC file. We'll press List Program, then navigate to the USB drive. Select the program and press F2 to copy it to memory. Loading the image is done the same way. When an image or video file is selected, the control will automatically place it into the User Data tab. Now that we're ready, let's cut our part. Just as we program, the machine goes into a program stop and displays the holder image. This prompts the operator to measure the tool projection. Once a projection is verified, the operator can continue the machining cycle. In this example, we're using M130 to display information about the tool projection. However, it's a great function for any type of setup data that you would like to pass on to the operator. Things like offset locations, how to load a part, or operate a tricky fixture can all leverage this functionality. This can even be used as a teaching tool in educational settings, or provide friendly reminders to an apprentice or new hire that's still becoming familiar with the machine and control. We hope this video has helped to spark some creative ideas of how you can leverage the M130 command in your Haas Next Gen control.